Good morning, everyone. 11 o'clock.
Good morning.
Just want to let y'all know before we begin that we have some family in town for graduation stuff today. So I have a little nephew who's 3 years old, and he's not here right now, but he's about to be back, and he could come barging in here, and he's a little wild. So just FYI, if that happens, it's out of my control. So okay, let's start off with questions. Last class, I got to the end. I was trying to show you all this thing with Gauss. I'm going to come back to this at the end of class today, but any questions over what we were covering? I ended with order of operations. I only did one example, and I sent you off to do homework. So I'd like to entertain any questions that you might have. I'm going to do a few more order of operation problems, but is there anything that specifically from homework you'd like for me to discuss? It's okay.
For me personally, it was the fractions, just number 23 with the cupcake one. It was
okay. Yeah. You're referring to the homework, right?
yes.
Okay. So let me bring up that problem. Number 23. Oh wait, is that the homework? Sorry. Yeah. Okay. So this one right here. Hold on. Got to open up another program. Hold on just a second. It's coming up right now. Where is it? There it is. Okay. Yeah, this is a very common question that I get for this problem. So let me put that here. Okay, so Sheila was making cupcakes for school, for the school parent-teacher dinner. Sheila knew she had to put in 13 2/3 ounces of ingredients. She had mixed together in the blender. After she was finished, she poured the mix into 2 1/4 ounce cupcake tins. How many cupcakes would one batch of this mix make? So, Bonnie, since you asked the question, how did you approach this?
I converted the mixed numbers into an improper fraction. And then I kind of just went from there. But for the improper fraction, I got 41/3 and then 9/4. And then that's just kind of where everything was kind of going berserk. So
okay, so you converted them. Were you having trouble with what operation to use to get the answer?
I had put addition, but for the first question, because it says how many of the cupcakes would make one of these batch, just for the first question, I put addition. So I don't know if that was right.
Yeah, so let's do this. Remember how I said last class that sometimes if you just change the numbers into nicer numbers, it just all kind of makes more sense. So let me change 13 2/3 ounces into like a nice number like 14. And then this 2 1/4, let me just change it to like 2. So if we read it now, it says Sheila knew she had to put in 14 ounces of ingredients into a mix, right? So she's got this mixing bowl. She's put into this 14 ounces of stuff. And then she's going to be pouring those out into, I don't know, those little baking sheets with that little cupcakes, you know, I guess people know, right? And each one of these cupcakes takes 2 ounces, right? So the question is, how many cupcakes can she make with that mix? So does that help you see what the operation would be?
Yes, I see it now.
So what would it be? What is the operation?
Division.
Division, right? It's how many times can that go into that? So you'd be doing like 14 divided by 2, right? And that would be 7. So she could make 7 cupcakes. So that's exactly what we're going to do, but we're going to be using the original values, so 13 2/3, and we want to divide that by the 2 1/4. Now, you said you converted these over to improper fractions, so you got 41/3 divided by 9/4, yes? Okay. Anybody have any questions on that so far? And then at this point, because it's division, we can do the keep dot flip, right? So we'll keep the first fraction. We'll turn it into multiplication. We'll flip the other fraction over. So 4 on top, 9 on the bottom. Be careful here. You are not allowed to reduce this fraction at this point. You might be tempted to cancel the 3 and the 9, but you're not allowed to do that until after you've done the flipping. Okay, very dangerous. Okay, so here at this point, we cannot do any canceling. Like there's nothing that cancels. So we're just gonna have to do multiplication of fractions. So we're just gonna go straight across. And this is where you'd want to have your calculator handy if you can't do the multiplication. So we get what, 164, I think, on top over 27, right? And that technically is a correct answer, but it wants to know how many cupcakes, right? So let's try now to convert that back into a mixed number. So to do that, you have to go back to the old school division like this. And if you have trouble with this, you can just do this on your calculator, 164 divided by 27. And you'll get, if I do that on my calculator, I get 6.07, something like that. So that tells me that if I multiply by 6 times 27, that gives me 162. Then I subtract to get a remainder of 2. So I put 2 over 27 here. So if we do this division, this becomes 6 2/27. So the answer to the question is 6, because you can only make 6 full cupcakes. You can't quite make 7. So you'll have a little bit left over, right? That's your leftover, but they want to know how many full cupcakes. So 6 would be the answer. And then how much is left over? So it says, how many cupcakes can you make? That would be 6. How much is left over? 2 over 27, and that's ounces.
Oh, okay. Yeah, I got it. I had a little bit of help, but I mean, I got the answer, but it was just kind of confusing at the moment, but it makes sense now. Thank you.
Okay, good. Thank you. Thanks for asking. Okay, let's see. Bayla, is my audio working now for you? Are you okay? I think everyone else can hear me, so. All right. Okay, any other questions over anything?
I wasn't able to figure out 13. Like I didn't get the answer on the bottom.
Okay, is that word problems also, or is that?
No, it's just, yeah, just no, up there, go back up.
Oh, go back up?
Yeah.
This one here?
Yeah.
Okay. So let's see. And remember, everyone, the answers to these are at the end of the packet, the odd ones. So if you're checking your answers and not getting what the key is putting there, so you can just verify. Okay, so we have multiplication, right, of 2 fractions. And so again, I think the best thing to do here would be to convert it over to improper fractions. So to convert 3 halves over, we go 3 times 2, which is 6. And we add the 1, that gives us 7 over 2. And we multiply that by same thing, 4 times 3 is 12. Add the 2, we get 14 over 3. And then we can just multiply straight across. You can also reduce, if you'd like, you can reduce now, which I think I'll do. I see that 2 goes into 2 once and 2 goes into 14 7 times. And now when I multiply straight across, I get 49 over 1 times 3, which is 3. So you should get 49 over 3, which I would accept on an exam. I would accept that answer.
You said to make it an improper fraction, we do You said 4 times 3 plus 2?
Yeah, so let me try and do this. Yeah, let me just take this one in particular. To convert that to an improper fraction, what you're going to do is you take these two and multiply, get that answer, and then add that number. And that becomes the top number right there. That becomes the 40, that becomes the, well, in this case, it would be 4 times 3, which is 12, and then add 2, that would give you 14. And then you divide that by, you always divide it by whatever number's here. So that would just come here and become 3.
Okay. Yes, sir. Thank you.
Okay. Now, I mean, I could show you this in like a formula, like as a formula, but it might look pretty ugly, but I'll do it anyway. If we have a mixed number, A, and then like B over C. So in this case, it would be like the 4 is A, right? The B is 2 and the C is 3. If you want to know like a way to convert it, what you're going to do is you're going to take A times C and then add B and divide the whole thing by C. I know that looks weird, but that's what we're doing. We're doing A times C plus B and then dividing it by the C, and you get the same result. So that's a formula if you like formulas.
Okay. Thank you.
Mm-hmm. So my guess is that the solution in the back does not look like this. They probably converted this back to a mixed number. So you'll have to do 49 and divide it.
Yeah, I got what you have,
Okay.
but just in the back, because I turned it into a mixed and it was 16 or 16 and 1/3, but in the back it said 6 1/3. I don't know if it's a
Okay, that might be a
typo or
typo.
not.
Let's see. Let's
Okay.
check it. If we do 3 goes into 4 one time, we put a 3 here, subtract, get 19, 6 there, that gives you 18, subtract 1, so you'll get 16 and 1/3. That's not what it says? I believe you. Let's
It's
see.
all good. I'm like 268.
What is it?
Oh, 268.
It's on 268, the page. I'm looking for
Yeah.
the answer. Oh yeah, it's 268.
Excuse me, mister.
Yes.
I'm having some technical trouble with the camera, so I'll be leaving the meeting and rejoining.
Okay.
Okay.
Where is it? What am I missing here? You said 268, right? There we go.
Mhm.
Yeah. Okay. Good. Let me write that down. The people who wrote this packet asked us to do this. 268. 2 fractions. Okay. Okay, good. Anything else that you'd like for me to cover homework wise? Okay. I'm gonna do some more order of operations. So let's start with that. Okay, so we talked last time about how it's important that we follow the Pemdas and that we remember multiplication and division, addition and subtraction. You go left to right, that it's not multiplication before division, unless left to right, that's what you have. So I wanted you to look at these problems, and I'll do a couple of them, but I want volunteers to just kind of tell me which one they want to see. So look, and there's more, but let's just off of the ones you can see right here. Does someone have one that they are looking at and they're like, ooh, I don't know if I could do that.
Could we do 6?
6. We'll start with 6, and then I heard someone else say something. So let's start with 6. Yeah, so 6 looks pretty complicated. lots of, it's fractions, but then within the fractions, you have other fractions. So we call this a complex fraction. And notice that we have this big division bar here in blue. And then above it, we've got two fractions above that, right? So what I'm going to do first is I'm going to try and put these two together, try and add those. So to do that, I'm just going to go over to the side here and do scratch work. Okay, so this is kind of, I'll put SW for scratch work. I'm just going to add those two fractions together. And then back over here, I will put my answer, whatever I get, right up there, right up here. Okay, so we are going to add two fractions. They do not have the same denominator, right? 5 and 3 are not the same. So I showed you there are kind of two ways to go about this from last class. And certain students like to do it certain ways. I'm going to do it the shortcut way, which means I'm going to take 2 and 3 and multiply them. That gives me 6. Then I put the addition symbol, then 5 times 1, which gives me 5. And then divide that by the 5 times 3, which is 15. And that gives me 11 over 15. Questions on that? So that's what's up here, 11 over 15. Okay, now what I'm going to do is I'm going to do the 2 cubed, 2 raised to the 3rd power. That's an exponent, right? So I'm going to do that now. 2 to the 3rd power just means 2 times 2 times 2, and that's going to give you 8. So I have 1 plus 11 over 15 over 8. Now this right here can be a little bit complicated, all right? So I want you to think about something. I'm going to show you a different problem, and I want us to talk about it because there's something subtle and important in the problem, all right? So over here on the side, I want you to consider this. What is 16 over 4 over 2? So what do y'all think? Anyone have a guess as to what the answer is here?
Is it 2?
Okay, so 2, someone's saying the answer is 2. Anybody think it's something different?
Maybe 4.
Maybe 4?
Yes.
Okay. Anyone else have something else? How about 8? Do y'all see how to get 8? So let me run through this. One thing I could do is I could first do 16 divided by 4, couldn't I? What's 16 divided by 4?
4.
4, okay, that give me 4, and then divide that by 2, and 4 divided by 2 would be 2, right? That's one way I could have done it. But another way I could have done it is I could have done the 4 divided by 2 first. 4 divided by 2 is 2, isn't it? And so I could have said this is 16 divided by 2, which would give me 8. Y'all see that?
Yeah.
So this is a trick question, okay? It's a trick question because I want to know which of these is correct, or are they both correct? But that's a trick question because the way I wrote the problem is actually incorrect, all right? Meaning when you have a fraction divided by another fraction, the length of the bar between the fractions is vitally important. And if you keep the lengths of the bar the same, then there's no way anyone can answer it correctly. So both of these could be right, but the fact that it was written incorrectly means that we shouldn't be able to get an answer. So this would be wrong. What I would have to do is write it like this: 16 divided by 4 divided by 2, or I write it 16 divided by 4, and then all of that divided by 2. So do you see how in these two different scenarios, I changed the length of the bar, the division bar? That is so you know what to do first. And in the first case, you would do this first in yellow, you do that first, and then you get an answer of 8 here. And if I wrote it this way, then you would do that first, get 4, and then divide it by 2 and get 2. So the reason I'm saying that is because when you go back over here to the problem we're looking at, we have a fraction, right? But then you have another division bar. Do you see how this bar is bigger? That bar being bigger means that it's not 15 over 8. You know, it's not 11 divided by 15 over 8. It is 11 over 15 divided by 8. And those can give you 2 different answers. So just pay attention to the fact that the length of the bar is important in the problem, in any problem that has multiple fractions in it. Okay, let's get back to this. We're not done. All right, so now what I'm going to do, this part's going to look a little weird. What I'm going to do is I'm going to try and figure out what this is right now. Okay, so again, I'm going to go on the side and do some more scratch work. I want to know what 11 over 15 divided by 8 is. Right, that's really what that means. Right, that's what that means. And division can be looked at as the keep dot flip, right? Anytime we have a fractions we want to divide, we do keep dot flip. But the thing is, what am I going to flip? Because 8 is just 8. So how do I flip 8? What do I have to do?
I mean, if you put a 1 under the 8 and then flip it like a reciprocal like that.
Exactly. We have to realize that 8 is the same as 8 divided by 1. And that way we can see that there is something to flip. So my next line is going to be 11 over 5 times, now that's my keep dot, and then here comes the flip, like that. And now I'm going to just multiply.
It's 11 to 15.
I'm sorry. Oh, I forgot the, sorry.
Yeah.
I think it's 15. Sorry, everyone see, I forgot the 1 on the 5 there. 15. Thank you. And then I multiply straight across. So I'll get 11 over, and then we do 15 times 8, which just verify on the calculator, get 120. And that does not reduce. So here I have 11 over 120. We're almost there. Now we have to add these two together, right? So the way we can add these together is by looking at them as both being fractions. So I'm going to rewrite 1 as 1 over 1. And then 11 over 120 is just itself. And then I'm going to do what I did earlier. Remember when I added these two fractions up here together? I did that, and I did that little multiply, go across thing. I'm going to do that. I'm going to do that here. So I'm going to multiply that times that. That gives me 120. 1 times 11, so I'm going to add to that 11. And then I'm going to divide that by these two multiplied, which is going to be 120. So I should get 131 over 120. That would give you full credit on this problem. If you look in the back, the answer key, and they have it converted back to a mixed number, that's fine. But on your test, I do not need a mixed number. Okay, you can leave it as an improper fraction. In fact, if you were to be doing more math, like going on to take pre-cal and calculus, and we never use mixed numbers. It's almost exclusively improper fractions. So leaving it like that's fine. Any additional questions on that problem? That's a good problem.
When we turning in the homework, you want us to show you all of this, like
No, so homework is not going to be collected or turned in. What I've asked you to do is keep like all your homework together in a binder, and then at the end of the semester, I will ask you to. I'm sorry? Did you say something?
Oh.
I think you disappeared. Right?
No, sir.
I discussed this the first day last class that we'll do something as like a bonus for you with your homework. Just keep it all together because the answers are all there provided for you. So it's really just a matter of you practicing. That's the whole purpose of the homework. but just keep it all together in one place, and I'll ask you to kind of submit something to me at the end of the semester. Okay, so what about another one of these? So we did number 6, last class we did number 1, so we've done those. What else do you want to see? I think Bayla is saying 2. You want to see 2 still, Bayla?
I think she was answering one of the questions. She had asked if we covered
Oh,
15,
okay.
so maybe 15 though.
15? Don't want to see 15?
Yeah.
Okay. Why are y'all being so quiet today? Everyone's being so timid. What's going on?
Cheyenne says she's not feeling well in the chat. And then
Oh,
Bayla said her mic is off.
Okay. All right. Well, I try and keep up with the chat, but it's hard because I've got too many things going on here. All right, so here we go. We're trying to do this order of operations. Let's talk about order of operations. So parentheses, exponents, multiplication, division, addition, subtraction, right? So first thing I do is I look in the parentheses because I have some, and in here I have a fraction 1/2. Can't really do anything to 1/2. I mean, 1/2 is 1/2. So then I look at, do I have any exponents? And I do, right? I have an exponent right here, squared. So I've got to take the 1/2 and square it first. And the definition of squaring something is multiplying it times itself, right? So I'm going to do this on the side again, like scratch work. I'm going to do 1/2 squared, which really means take 1/2 and multiply it times itself, 1/2. And multiplication just goes straight across. So 1 times 1 is 1, and 2 times 2 is 4. So you get 1/4. That's kind of a weird thing if you think about it for a minute. Most people think that when you square a number, it gets bigger, right? Like that's kind of a common idea. Like if you take the number 3 and square it, you get 9. If you take the number 4 and square it, it becomes 16. But if you take a fraction and square it, it actually gets smaller, right? We started with 1/2 and we squared it and it became 1/4. It's kind of an interesting property of fractions. Actually, it has to be a fraction between 0 and 1, but it actually gets smaller when you square it. So we get here 1/4, and then we have to add to it 1/5. And then we're back to adding fractions. So do y'all want me to keep doing the little shortcut way, or do you want me to show you the other way for this one? Kind of up to you.
We can
Shortcut.
do the shortcut.
Short? Okay, I like the shortcut. So here I multiply, I get 5. Here I multiply, I get 4. So I'm going to add those together, and then over multiply those two together, and I get 20. So 9/20 is the answer. Okay, I'll do one more. If you want to see one, I'll do one more.
Let's try 13.
13. Okay, we're gonna do that one now. Ooh. I'm surprised with the ones y'all are picking. Most time students pick the ones that look really crazy. Y'all are picking the ones that look like they're not bad. But hey, you know, it is what it is. Here we go. So we have a couple of numbers here. We have multiplication here and we have division here, right? Multiplication, division. So which do we do first?
Wouldn't it be left to right?
It's left to right, right? So it's not that we're doing we are going to do the multiplication first, but it's not because it's multiplication. It's because it appears to the left of the division. So we're just going to do it like we read a book. So I'm going to maybe do scratch work again on the side. I'm going to do 1/2 times 8 first. And when I do that, I have to remember that 8 can be written as 8/1. And that way I can just do my multiplication straight across. And when I multiply straight across, I get 8/2. And 8 divided by 2 is just 4. So that means that this is equal to 4 divided by 6. Okay, I want to divide these two. So I'm going to try and convert these into fractions so I can do the keep dot flip. So when I do that, I'm going to rewrite 4 as 4 over 1 divided by, I'm going to rewrite 6 as 6 over 1. And then I'm going to do keep dot flip. So keep it as 4 over 1, dot, flip it, 1 over 6. And now multiply straight across. 4 times 1 is 4, and 1 times 6 is 6. So you may have just been able to look at that and say, oh, well, 4 divided by 6 really just means 4 over 6. I understand that, but I'm trying to illustrate again to you how we can use fractions to pretty much break down all of these problems. And that actually reduces, right? Because 2 goes into 2 there, and 2 goes into there 3 times. So it becomes 2/3. Okay, we're going to move on, since there weren't any other requests, to the next topic, which is solving linear equations. So before I begin this, I want to make sure everybody is clear with the difference between an equation and an expression. Okay, so equations versus expressions. All right, so I'm going to write down examples of each, and we just want to be clear with what we're looking at. So if I write 3x plus 1 equals, let's say, 10, and over here I write 3x plus 1 minus 10, those look like almost the same thing, right? These are almost the same exact things, but there's a huge difference between the two. The first one is an equation because it has an equal sign in it. And so when we look at this equation, what we're going to try and do with it is solve it. In other words, we're going to try and figure out what x is that makes this true. Okay, so for example, would you all agree with me that if x is 3, if I put a 3 right here, then it'd be 3 times 3, which is 9, plus 1 would be 10, but that is equal to 10, right? If I replace the x with 3, this would be true. If I replace it with 5, it won't be true, right? So when you have an equation, what you're trying to do is solve it, which means you're trying to find some value of x or whatever the variable is that makes it true. When you have an expression does not have an equal sign in it. And so you can't solve it for anything. You're not trying to solve for x. All you're ever trying to do is rewrite the equation and make it look nicer or cleaner. And so for this expression, one thing I could do is I could put the 1 and the negative 10 together because those are both numbers. And I could make this 3x and then make that minus 9. Because if I take 1 and subtract 10, I get negative 9. And that would be it. That's my answer. Okay. It's just all we're doing here is rewriting it in a cleaner form. When I mean cleaner, I mean like simplified, okay? Just make it look nicer, okay? If there's numbers, put them together. If there's variables, you can combine those. It's called like terms, and we'll discuss it more as we get to it. But the big thing is when you're looking at something, you have to know the difference between equation and an expression because that dictates what you're going to do. So what we're going to talk about right now is how to solve linear equations. Now this concept of solving linear equations, this word linear is important. What the word linear means is that you're looking at equations, so something that has an equal sign in it, right? All of these have equal signs in them. Okay, that's what makes them equations. But what makes them linear is the fact that everywhere in these equations, we have x's. It could be other letters too. It could be, any letter you want, but in like t here, right? All of the x's or t's or whatever their variable is, notice that on every single one of them, they are all raised to the first power. So like if I just write x down, what I really mean is x to the first power. It's not, none of these are squared or cubed. There's no like square roots over the x's or the variables. It's just the variable by itself. And that's what makes them linear. So when you solve a linear equation, we have a set of steps to do it. Okay, there's like a procedure to do linear equations. If we change this linear equation to something different, like quadratic, like we'll do later, then the whole procedure changes. Okay, everything we do is different. So it's vital that when you're looking at an equation, you can recognize it's linear so you know kind of which path to go down. Does that make sense? Like you want to know what you're looking at because it dictates, you know, what technique you're going to use. Is that clear? No? Okay, so let's talk about the procedure for solving linear equations. I'm going to write it down. It's a step-by-step process. All right, so to solve linear equations, you will first make sure it's a linear equation. Okay, so you want to make sure you know what you're looking at, all right? So just be like, oh yeah, that's a linear equation. Okay, so make sure that's what you have. Second step is to clear fractions or decimals. Clear fractions or decimals. And to do that, what we will do is multiply both sides of equation by some number, okay? And as we do some problems, you'll see how this works, okay? So if we have a linear equation, then the first thing we're going to look is make sure it's linear. Then we're going to clear any fractions or decimals if we have them. And to do that, we'll multiply both sides of the equation by something. The next thing we'll do after that is to remove any parentheses on both sides. And to do that, we will have to do something called distribute. And again, you'll see as I do some examples how this is going to work. The fourth thing I'm going to do is combine like terms. On both sides. And then what we're going to do is isolate the variable. I hate writing steps out without going through an example first, but I'm going to write them all out and then we'll use the steps to do an example. So we're going to isolate the variable, and to do that, what we will do is either add or subtract on both sides of the equation. And our goal will be to isolate the variable. Isolate the variable means get the variable term by itself on one side of the equation. Okay, so get it isolated. And then last step, we will make sure the number in front of the variable, which is called the coefficient, is 1. That's a 1. And to do that, we'll have to divide both sides. Okay, that's it. 6 steps. So let's take our first example here. And I'm going to clear out all this stuff here. Okay, maybe I'll grab all of them. Let's grab them all. I'm going to make them real small over here so I can grab them one by one. All right, so let's take a look at number 16 here. I'm going to try and solve this linear equation. Put this over here. Get out of here. Okay, so I'm going to try and solve this linear equation. So the first thing you do is make sure that you have a linear equation, right? So let's see. There were some people I didn't call on last time. Is it Elisa? Elisa? Is that right?
Yes,
How's it going?
good. How are you?
I'm doing okay. So the first step for this is to make sure that it's a linear equation. So is this a linear equation?
Yes,
How do you know?
because of the equal sign
And
and because you're solving for a variable, which is x.
X, and it's not like X squared or something like
Mhm.
that, right? It's just X is in there. Okay, good. So it's linear. Now, Elise, is it Elisa? Elisa?
Yes.
Look at step 2. Clear the fractions or decimals. Elisa, do you see any fractions or decimals?
No.
No, so we're just going to skip that step, right?
Mm.
Okay, I'm going to stick with you on this. How about the next step, 3? Remove the parentheses on both sides, and to do that, we distribute. Do you know what that means? Because we do have a parenthesis.
No, I don't think I know what that means.
Okay, so you see the 5 that's in front of the parentheses here?
Mm-hmm.
Okay, we want to get rid of these parentheses. The only way to get rid of those is to take that 5 and distribute it through the parenthesis, which means we want to, this is a multiplication, we want to multiply the 5 through to the x.
Okay.
Yeah, so you probably have done that. You just maybe don't remember what it's called, but now that I've shown you, that makes sense.
Mm-hmm.
So what would I get if I did those 2 multiplications? What would I get on the left side?
It would be 5x minus 10.
Good, 5x minus 10, and then I continue to write the equation, and Elisa is done. Good job. All right, how about, is it Piero? Hope I'm saying that right. Piero, you with us today? I don't see Piero. Oh, what's that? How about Sergio? Oh, you know what? I think Sergio's changed classes. He was in the wrong class. Emily?
I think that's me. I go by Caitlin, but my first name is Emily, so it's probably on.
Okay, yeah, I'm gonna change it in my roster. That way I call you Caitlin from now on. Let's see. Okay, so Caitlin, we've done the first 3 steps. So the next step is to combine like terms. And what I'm doing with this is I'm trying to kind of see where everyone is. Like as I'm calling on you, I'm trying to kind of gauge where people are. So Caitlin, what can you say about combining like terms?
Couldn't you bring the 10 over and then bring the 4 over?
Okay, so you're talking, when you say over, you mean like to the other side of the equation?
Yeah.
Yes. What you're doing is you are doing step 5, which is to isolate the variable, which means you're moving things around, which is going to come, but look at step 4, combining like terms. So what that means, Caitlin, is look at the left-hand side and tell me, can you put those together? Can you combine 5x and minus 10 together?
No.
No, right? Okay, that's because they're not like terms. If we had like something like, maybe we had like a 2x in front of this added, then you could combine the 2x and 5x together and make it a 7x, right?
Mm-hmm.
Or if I had like more numbers over here, I could combine those together. But we can't because they're not like terms. So Caitlin's saying on the left side, we cannot combine anything together. And Caitlin, how about the right side?
No, you can't combine anything.
Can't do anything, right? So we have done now step 1, 2, 3, 4. And then now is the time, Caitlin, to isolate the variables. So you said we're going to move things around. So how do we get x's by themselves on one side of the equation? Like, how can we do that? Go ahead. You'd already told me what to do.
I don't know if this is right, but couldn't you do like put like minus 4x underneath and then bring it over, and then underneath the 5 do minus 4x?
Okay, that's exactly right. So think about what you're doing by doing that. What Caitlin has decided is that she would like all of the x's to be on the left side of the equation. That was the decision made by Caitlin. And to do that, she wants to remove the 4x from the right side. So she's just going to subtract it. Okay, so let me do that. You said subtract 4x here, but whatever you do to the right side, you must do to the left side. So you subtract it on both sides like that. Okay, go ahead, Caitlin. What is 5x take away 4x? What does that give you?
Just be x.
Just x. Okay, now we still have minus 10 equals, now 4x, you took away 4x, that leaves you nothing, and you still have minus 10 there.
Mhm.
Okay,
So then you would just like get the 10 over. So then it would be like addition. So like plus 10, and then on the other side plus 10.
exactly. So continuing with this idea that Caitlin has here is to get the x's on the left side. To get the x's on the left side, she has to remove the negative 10 from the left side. So to remove the negative 10, we're going to add 10 to both sides. Okay, so you're doing the opposite of what you see there, and then add that. Let's see what happens. This goes away, right? Negative 10 plus 10 is gone. You have x, then equals here, negative 10 plus 10 again is what, 0?
Mhm.
So your answer is 0. So x must be 0. Well, hold on. That's step 5. We have isolated the variable, haven't we? Now, the last step is to make sure that the number in front of the variable, which is called the coefficient, is a 1. So do we have a 1 in front of this x? If it's not there, it's a 1, right? So at that point, our step 6 just happens to be done at this point. So our answer is x is 0. Now, good, Caitlin, you're off the hook here. So let's just make sure we understand what we're saying here. We're saying that if you take this equation and you replace all the x's you see with zeros, right? Because our answer was 0. If I just rewrite the problem and I replace all the x's with zeros, this should be a true statement when I'm done. So now I have to simplify this using order of operations. This becomes 5 times, when I put those together, 0 take away 2 is negative 2. Then over here, 4 times 0 goes away, I'm left with negative 10. And when I multiply those together, I get negative 10, and that does in fact equal negative 10. That's a true statement. So we have found the value of x that makes this true by following this procedure. Now, I realize there are a lot of you in here that can do this and you don't have to go through the 6 steps and everything else. I'm presenting this to you in a way that if you're like, have no idea how to solve linear equations, now you kind of do, right? You have a procedure to follow. Questions? I'm about to do the next one. Well, I'm not going to do it. I'm going to have someone help me do it. Let me do it this way. I'm going to move all this down so we can keep the steps in front of us here. All right, so here we go. Caitlin's good. Who do we not hear from? How about Luis? Luis?
Yeah.
Okay, how's it going, Luis?
Good, good.
All right. How do you feel, Luis, about solving linear equations? Like your background with it? Do you feel like, yeah, I've done that before?
Yeah.
Good?
After doing that equation, I remember doing it in
Okay.
school, kind of. So, kind of, you know, doing.
Yeah,
good,
yeah. I mean, you've done it before, just
yeah.
not something
It's
new.
coming back. It's coming back. Yeah.
Okay. So, we have to be just careful, right? That's the thing about math. You just have to be careful, right? Little things that can get you. So let's just take our time through this. Luis, this is a linear equation, yes?
Yeah.
Okay, so let's go to step 2. Do you see any fractions or decimals?
No.
No?
No.
No, right? And if you're confused on fractions and decimals, just look at the other problems where you look at number 20, right? You see the
Mhm.
fraction.
Yeah.
Here you want to see fractions. So we will get to them. We're just not there yet. So
Yeah.
no fractions. Okay. How about parentheses? You see parentheses?
hmm
Okay. So how can we remove the parenthesis that's on the right-hand side?
Will you distribute?
Distribute. So we take that 3, we multiply it through the parenthesis.
Mhm.
So let's see how you do with that. I'm just going to rewrite everything.
Will it
What do you get?
be 6x minus 12?
Yep, 6x minus 12, good. And that's step 3. Okay, I'm going to keep going with you here, combining like terms.
hmm
So look at the left side by itself.
Yeah.
Can you do anything to put those two together?
Yeah.
Yeah, so if you have two cell phones and you take away 5 cell phones, how many cell phones do you have?
I have 3.
-3, right? So this is going to become -3x.
Mhm.
Now on the right side, Luis, can we put those together?
No.
No, so we leave it, right?
Mhm.
Okay, good. All right. All right, I think I'm going to let you off the hook. Good. I'm going to call on Lily. Lily is our new classmate. Lily, how are you doing?
Pretty good, thanks.
Good. Okay. Throw you right into the fire here. So Lily, how's your background with this?
Pretty much the same.
Okay.
I've definitely done this before, but it's good to like see the steps again so I can remember.
Okay, good. So we are at the step now of trying to isolate the variable.
Mm-hmm.
Okay, so how would you see x's on both sides, right?
Mm-hmm.
Okay, so earlier, Caitlin decided to move all the x's to the left side. And that was, I guess, just her choice, right?
Mm-hmm.
And there's no rule that tells you which side you have to do it to. Like you can move them to the left side or to the right side. It's totally up to you. Most students do it to the left just because that's the way they were taught. It doesn't matter at the end. We'll get the same answer. So when you look at these, what do you think would be the easiest way to get your x's onto one side? What would you do?
I would move the 3x over to the right side
Okay.
because when you move it over, it becomes plus 3x, and
Okay.
6 plus 3 is easier to add to me.
Okay. So you want me to do what to both sides right now?
Isolate the variable.
Yes. So you said you want to move the 3x to the other side or something like that. So how would you do that? What do you have to do on both sides to do that?
Add 3x to
Okay, so
6x.
you're adding because it was a negative sign there, right? So you have to do the opposite. So you add 3x there, add 3x there. Now, Lily, what do you get on the left side when you do this operation over here? What is left on the left side?
Nothing, so then you have to move over the 12.
There's nothing there, right? So I'm going to put 0 equals, Lily, what is the 6x and 3x added?
9x.
Okay, and then you still have the -12, right?
Mm-hmm.
And I heard you say it. Now you've got to move the 12 to the other side. How would you do that?
Plus 12, so 0
Plus
plus
12.
12.
Plus 12 plus 12. And now you have 12 equals 9x. Good. So Lily has isolated the variable, right? She's got the stuff with variables on one side. But there's one more thing we have to check, and that is that the number in front of that variable is a 1, which in this case it is not. It's a 9. So the final step, Lily, will be to somehow get rid of that 9, and this is where we will divide both sides by something. So divide by what?
9.
9, okay, and that's because 9 divided by 9 would give you 1. So cancel that out, you just get 1x equals 12 over 9, and that's a fraction that can reduce, right? 3 goes into both of those, 4/3, right? 3 goes into 9 3 times, 3 goes into 12 4 times. So our answer is 4/3. And that means if you go back up to the original equation and you replace every x with 4/3, it should be a true statement. Okay. why would you ever need to solve a linear equation in the real world? I'm like when would this ever come up, right? I'll give you a very basic example. Okay, and this may still seem like that's not realistic, but just to give you something just that maybe you've never thought about. I know some of you work, right? If you, let's say that I'm trying to think of a job that, okay, let's say you make like $12 an hour, okay? And let's say that you also get, and this is the part that isn't going to seem realistic. Let's say that your parents are still helping you out and they give you like $200 a month to help you out, you know, as you're in school and they're trying to help you, okay? So you make $12 an hour and your parents give you $200 a month. And your bills every month come out to be about, I don't know, $1,200, okay? So I'm going to just jot this down. You make $12 per hour. Your parents give you $200 a month. Okay, that's what comes in. Okay, your out for the month is $1,200. My question is, how much do you need to work just to be able to pay your bills? Right? How many hours do you need to work to pay your bills? Well, the variable here is how many hours you work, right? You're going to make $12 for every hour. So if I let X be the number of hours, then if I write $12 times X plus the $200 my parents are going to give me, that must equal the $1,200 that goes out. Does that make sense? $12 for every hour I work plus the $200 that my parents are graciously giving me. That must equal the $1,200 to pay for the apartment, blah, 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 whatever else it is. This is a linear equation, right? You can solve this for X and you just go through and run through the steps. Does that make sense? I mean, it's just kind of an illustration of how in the real world you can use linear equations to solve problems. All right, let's get to another one. The next one's looking pretty bad. Who's going to be the lucky one here? I'm just going to start this on a new page. Okay, Evelyn, I do not believe we talked last time. Is that correct? I don't see Evelyn here. I have one person here who's logged in on a phone. Your phone number is being posted to everyone. That's fine with me, but I don't know who you are. So you might want to send me a chat. That way I count you as being present today. But let's see, Evelyn, no Evelyn. Who else? How about Cheyenne?
Yes, I'm here.
Okay, how's it going, Cheyenne?
So.
So you're not feeling well. Do you want me to just get you on another day? Is today one of those days?
I mean, I can try. See how well my brain's working.
Okay. All right. Do you feel like linear equations is something you've seen in the past that you felt pretty good about when you did it?
Yep.
Okay. All right. So I'll run you through this. It's a linear equation, right?
Quit.
And there's no fractions or decimals to clear, but you've got parentheses. So
So on the other side, or on your left side, because there's nothing to, there's nothing that you're actively having to multiply. So it would be 10x plus, it would just be 10x plus 4 minus x.
yes, I agree. That is correct. There is actually something here in front, but it's a 1.
Yeah.
So the 1 gets distributed through, and that's why nothing changes. So good. I'm with you on that. The only reason I want you to everyone to think about that being a 1 is because had this been minus right here, then you would be distributing a negative 1 through the parentheses, which would change things. Okay, keep going.
And on the other side, you have the 7x plus 2 times that, so you distribute the 2, so it would be 6x plus 10.
Okay. Good, good. I'll do one more step with you, and then we can move on to someone else. The next step is to combine like terms. So Cheyenne, anything on the left that you can combine together,
The 10x and the x, the negative x,
and those become what?
9x.
And then plus 4. And then on the right side,
The 7x and 6x, which would be 13x
13x
plus 10.
plus 10. Okay, good. You're good to go. Thank you. All right. Let's see. I'm going to go back and just kind of go. I've gone through everyone the class should have been gone through either today or last class. How about Deanna? You there?
Dina.
Deanna. Okay, say it again.
Dina.
Deanne. I'm going to have to do something here. I'm going to put D with a little hyphen in it. And that
No,
way.
it's Dina.
What?
Dina.
To Dina.
Dina. Okay, so, okay, then I'll put the hyphen after the D. That's what I'll do.
Okay.
That should help me. Okay, Dina. What next?
We're gonna put the like terms together on one side.
Mm-hmm. So how would you do that?
I'm gonna move the 9x to the right.
You want to go to the right? Okay, how would you do that?
By dividing by 9, it becomes negative 9x on both sides.
Okay,
On the
so
right.
you're going to subtract 9x, right? On both sides?
Yes.
Like that?
Yes.
Okay. And then what would be left? What would be left if we did just that step right now? What would my new equation look like?
It'll be 4x.
4? Just 4?
Yeah, 4 equals 4x plus 10.
Okay, gotcha. I'm sorry. Misunderstood. There we go. Okay, so that's the new equation. So we almost have the x's by themselves. What would be next, Dina?
We would shift the 10 to the other side.
By? How would we do that?
We would subtract 10.
Subtract 10, subtract 10. Gone. And
It'll be
Dina, 4 take away 10?
it'll be negative 6.
Negative 6, and that must equal the 4x that's there still.
Divide by 4 on both sides.
Yeah, so
So
we're
it'll
almost
become-
there. Yeah, we're almost there. We just needed to get a 1 in front of the x. So you divide both sides by 4.
Yes, and then we'll simplify the fraction. So we'll divide it by 2. It'll become negative 3 over 2.
3 over 2. There we go. Reduce the fraction out. Does anyone have a question on that? Okay, good. All right. How about this one? Let's do this. I'm going to let you try this on your own. Okay. Give you a few minutes to see if you can get to the solution x equals a number. All right. And then I'm going to call on somebody randomly. And it might be you. So we'll see how this goes. I'll give you, I don't know, 3 minutes. See how you do. Sorry, I was talking. I was muted. Okay, so I asked, did anyone have any questions with it before I call on somebody? Okay, Bonnie, you're up. So how did you do with it?
So I first did the parentheses, so I distributed first because there is no decimal or any fractions like that. So from going left to right, it's going to be a -1 for both of the parentheses. So if we're distributing, it would be -2, or it would be 3, and then -2 plus 7x because the negatives cancel out, so it turned into a positive. And
Okay,
then you,
all right, very good. So just make sure everyone understands what's happening here. -1 is multiplying times the 2, which gives you -2. But a negative times a negative gives you positive. So that's why we have plus 7x. Good, continue.
and then you would equal it, and then 2x, and then it would be a +5 because the negatives are together, which turns into a positive. And then same thing for the 1, so then it would be a +1 as well.
Good, very good, Bonnie. All right, how about Jamal? Jamal, are you here? Jamal, last call, Jamal. Okay. Katrina,
So after that,
so did you get that part, Katrina? You were
oh,
good with
yes,
that?
I did.
Okay, good. Okay, so after that, now what?
Combined like terms, so I got 1 plus 7x equals 7x plus 1.
Uh-oh. Okay. Interesting. All right. What did you do after that?
I subtracted the ones from both sides.
Okay, so you're trying to get x's. So you decided to subtract 1 on both sides. That's fine. You can do that. And that they go away on both sides, don't they?
Yes.
So you're left with 7x equals 7x.
Yep.
Okay, what did you do then?
I subtracted both of the 7s. So
So
would it be 0 or?
you'd have to subtract 7x from both sides.
Oh,
You'd have
yes.
to put 7x on both sides. That's the only way you can move it over is if you move the whole thing, which means you would get, this is weird. Okay, what would we get on both sides?
Would it be 0?
0 equals what?
0?
0. What? This is weird, right? Where'd the x go, right? The x is gone. We're not saying that our answer is 0, are we? We're not saying that. We're not saying x equals 0. This is a weird equation. This is the first time this has happened, where we got, at the end of the day, an equation that says 0 equals 0. Now, let me ask you, Katrina, is 0 equal to 0?
Yes.
It is, right? So what does that mean? This is a strange thing. When you're solving a linear equation, if you ever work it out following all the rules and get to an expression at the end where it's true, like 0 equals 0, or maybe it says 2 equals 2, or maybe it says 5 equals 5, what that tells you is that there are an infinite number of answers. In fact, any number you ever pick for x will work. So if I go back to this original equation and I plug, I don't know, Katrina, give me an x value, anything you want.
2.
2. If you plug 2 in here, it'll be true. I'm not going to do it, but you can try it for yourself. Plug 2 into this, it'll be true. If you plug in 5, it'll be true. If you plug in 10, it'll be true. So because of this, our answer to the problem is all real numbers. That's the answer to the problem. Any number you ever pick will satisfy the equation. The only way we know that is because at the end we got something here that's true, right? That's true. It's always true. Now, what if we had worked this problem out and at the end I got 0 equals 2, right? let's just say that we worked a problem out and at the end I get something that isn't true, like 0 equals 2. In that case, you would say no solution. Right? It could happen on problems you do for your homework, so just be aware of that. So when you solve linear equations, all linear equations, you have 3 possible answers. You could get a single number, like we did in the previous examples, we got just some number. You could get all real numbers, or you could get no solution. Those are the 3 outcomes that could happen. Any questions on that? We ready to do one with fractions? All right, this one's tricky. I'm going to write the problem out again here. 3t minus 7 over 2, the whole thing over 2 equals t take away 6. So this is a linear equation. And let's see, Tiffany, are you here? Tiffany, I don't see Tiffany. Okay, how about Diane?
Yeah.
How's it going, Diane?
It's going.
It's going?
It's going.
It's going. All right. You see fractions now? Do you see it? Do you see a fraction anywhere in the problem?
No. Well, left side, I guess.
Left side, right? The left side is a fraction. You've got 3 and then parentheses t minus 7, all of that divided by 2. So this is the first time we've seen this. In step 2, well, step 1 is to make sure it's linear. Step 2 is to clear fractions or decimals. Since I have a fraction here, and this is the first time, what I'm going to tell you what you have to do, because we haven't really gone through one of these. You're going to look at the denominator of all the fractions. So you might have more than one. In this case, we only have one fraction. You look at the denominator, and you're going to find the LCD, the least common denominator. So we want to look at all denominators. And then find the LCD, least common denominator. Now, in this particular case, the only denominator we have is 2. So that will be our LCD. Once we find it, we will multiply both sides of the equation by the LCD. That's the second step. This is what it takes to clear fractions. So Diane, what I'm going to do is I'm going to multiply both sides of the equation by 2. So watch the way this looks. 2 times the left side of the equation equals 2 times, now the right side of the equation, I have to put it in parentheses because there are 2 terms on the right side. They each have to get hit with a 2. So are there any any questions on that step for anyone in the class? Okay, Diane, I'm going to have you help me now. On the right-hand side, Diane, what do you do here?
You distribute the 2.
Okay, and if I do that, what would I get on the right-hand side?
2t minus 12.
Good, 2t minus 12. Okay, now Diane, on the left-hand side, this is the one that gets people, that trips people up. On the left-hand side, I want you to focus your attention on the idea that multiplying by 2 is the same as multiplying by 2 over 1. And Diane, what can I do with the 2's?
They cancel out, so you just have the top part left.
That's right, they cancel. And then you're left with 3 and then t minus 7. The whole purpose of that step is after you do the step, you should no longer have fractions. And we do not, right? No fractions. So Diane, what can I still do on the left-hand side?
Multiply the 3 or distribute the 3.
3.
So you get 3t minus 21.
Equals 2t minus 12. And now we're kind of at the easier steps now, like steps we've done a few times now. So I'm going to go through this a little faster now. Diane, you're off the hook. Thank you. I'm going to subtract 2t from both sides. That will make it go away on the right. I'll be left with just a t on the left. Minus 21 equals negative 12. And then I will add 21 to both sides to get rid of the minus 21. And that will give me t equals, okay, now be careful on this. That should give you 9. Look at that as being like 21 take away 12. So that should give you 9. So t is 9. Questions on that? Okay, I'm going to make one up. I'm going to make up my own problem here. I want us to do 3/4 x minus 3 equals 1/3 x plus 5/6. All right, this one's a tough one. Let's see who's up here. Let's see, Bela, are you there? I don't know if I can hear you though, right? I don't know if your mic's working. I think you can only chat if I'm not mistaken. Yeah, okay, so I'll come back to you. I don't know if that's going to be a common thing that's wrong, but how about Katrina? Katrina?
I'm here.
Didn't I call on you already?
Yes.
I did, didn't I? Okay. All right, who have I not called on? Let's see. Uh-oh. Is it Darshil? How do I say that?
That's correct.
Darshil? Okay, good.
Yes.
All right, so Darshil, looking at this linear equation, you see fractions, yes?
Yes, sir.
Okay, now when we look at the fractions, we have to look at all the denominators. And we're going to just list those out. We have 4, we have 3, and we have 6. We need to find the LCD, the least common denominator. That means we have to find a number, the smallest number we can find that is a multiple of all 3 of those. So can you tell me what it is, or do you want me to list out all the multiples? We'll start listing.
It should be 6.
It has to be a multiple of all of them though. So the multiples of 4 are 4, 8, 12, 16, 20, 24. Let me see, how far do we want to go? 28, 32, I'll go that far. Right, those are all the multiples of 4. All the multiples of 3 would be 3, 6, 9, 12, 15, 18, 21, ... keeps going. All the multiples of 6, 12, 18, 24, 30. So what's the smallest number that appears in all 3 lists? You see it?
12.
12.
Yes.
Okay, good. So 12 is our
Can
LCD.
you hear me?
I can hear you. Yes, I can hear you. I think you're kind of cutting in and out, but I got you. 12. So the
Yeah, that's
LCD
happened
is 12.
Monday.
Okay. So the LCD is 12. What do we do with that 12? What do we do? So what did we do on the last?
Do we do fraction?
When we looked at all denominators, we found the LCD, and now we will multiply both sides by the LCD. Both sides of the equation get multiplied by that 12. So
Okay.
here's where things are going to be weird. We're going to do 12 times the entire left side equals 12 times the entire right side, like that. And then we have to distribute. So here to here, here to here, here to here, and here to here. All right, I'm going to do the left side, and then I'm going to have all of you do the right side. So when I do the left side, when I do this first multiplication, I'm going to do it on the side. I'm doing 12 times 3/4 x. That's this first multiplication. And that's the same as 12 over 1 times 3/4 times x. And when I multiply fractions, I can go straight across. And I can also reduce if possible. So I'm going to reduce this. 4 goes into 4 once, 4 goes in here 3 times. And then I'm multiply straight across. I'm just going to get 9 over 1 times x, which is 9x. So just that first multiplication gives me 9x. And then the second multiplication, I'm doing 12 times -3, which is -36. Equals. Okay, take a moment to see if you can do the right side. And what we're going to do is it's 12:24. We're going to take our 10-minute break right now, but finish this right side up, and then we'll come back and we'll see what everyone has. But we're going to go with our 10-minute break right now, and then we'll resume class. So I'm going to set my little timer here. There we go. So we'll resume when that timer runs down. Okay, everyone, we're going to get back to work here. Okay, did anyone do the right-hand side and want to tell me what they got?
Negative 4x plus 36.
Where'd you get the negative 4x from?
It's positive, my bad.
Are you talking about the right side when you multiplied here to here?
Yes.
Okay, you should get 4x there
Yeah. 4x plus 36.
plus 36. How'd you get 36? You're doing 12 times 5/6, right?
My bad. I was looking at the next step. Yeah, it's 4x plus
Oh,
10.
okay. Plus 10. Okay, there we go. All right, so when you multiply there, you can reduce. The 6 goes into both 6 and 12, and then go across and get 10/1, which is 10. Does anyone need me to clarify the right-hand side, how we get 4x plus 10? So the whole point of step 2 to clear the fractions is so that you have a linear equation where you have nicer numbers to work with. And then at this point, you can continue doing the rest of the steps. I'm going to work through this quickly. I'm going to subtract 4x on both sides, which gives me 5x minus 36 equals 10. And then I will add 36 to both sides. And this will leave me with 5x equals 46. And final step would be to divide both sides by 5 to get a 1 in front of the x. And so you get x is equal to 46/5. Any questions? Okay, I believe we have more problems we can do here, but I think I'm going to leave you to your homework now for this section, and I'm going to move on to the next topic, which is linear expressions and equations. So in this set of problems, I want you to notice that there's a mixture of expressions and equations. So let me identify first the ones with equations. There, and there. All of those can be done using what we've talked about, those 6 steps. But the ones in green, those are different. These are expressions. So what we want to do is work with those and see, how can we do anything with the expressions, right? We're not solving like we were with the 6 steps. With the green ones, we're doing something else. So let's take these one at a time. So I'm going to take this one here. And the instructions here are to simplify. So we want to somehow put these things together, combine like terms. So I think most of you are pretty comfortable with the idea that if I asked you to add like 3x and 2x together, you'd add them up and you would just get 5x. And what you're doing there is you're just taking the 3 and the 2 and adding them, right? That's it. Here, we need to put these two things together because the 1 by itself, the -1, is not a like term. It doesn't have an x in it. So we can combine the part in yellow, but we can't combine the part in green. So how do we put those two in yellow together? Well, what you first need to realize is that x divided by 3 can be rewritten as 1/3 x. And then the other one is 1/4 x, and then we still have the -1. So that's critical that you understand that x over 3 is the same as 1/3 times x. And then just as before over here, all we're going to do is take the two numbers in front, and in this case, add them together. And I'm going to do that on the side. So I'm going to take 1/3, I'm going to add 1/4, and this will become 7/12. Now, how did I get 7/12? 4 times 1, 3 times 1, added those together to give me 7, and then multiply 3 times 4. So that's stuff we covered from previous classes, right? Adding two fractions. So this here becomes 7 over 12x minus 1. And that's it. There's nothing else we can do because it's simplified, right? We brought the two x's together into a single term, and then the minus 1 we leave alone. Questions there? Look at this next one here. For this one, same sort of story. It's not an equation, so we're going to try and put them together. So I'm going to rewrite this as 1/4 x plus 3x. And then I will look at the 1/4. I'm going to need to add to it 3, and I'll do that on the side. I'm going to rewrite 3 as 3 over 1. And then I'm going to add the fractions doing the little shortcut. So we've got 1 plus 12 over 4. So that was multiplying here and here and then here. So 13 over 4. And that's it. 13 over 4 is the new coefficient in front of x, and we're done. See, no equal sign in here. We're not saying that, x equals 2, or we are just simplifying the expression. Go grab the other one. Okay, so for this one, the tricky part of this one is that you will need to distribute the 3 first. Okay, so on the top we get 3x minus 9, all of that over 2, and then minus x. So just distribute to clear the parentheses. Now, a very important property of fractions. Okay, and I'm going to write the property over here just to make sure you have it down. If you ever have some number plus another number over a denominator, you are allowed to split this up into 2 fractions. So if we have 2 terms on top and 1 on the bottom, you can split it into 2. So watch what I'm going to do over here with this fraction. I'm going to rewrite it as 3x over 2, and then minus 9 over 2, and then minus x. So I took the 3x right here and I put it over 2, and then I used the minus sign, and then I put the 9 over 2. Are there any questions on that step? The reason I did that is because I wanted to get something that has x by itself, these two x's separated, and I can't do that if it's all stuck in this big fraction. So I split it apart, and now I'm going to try and put these two together. So I think I'll rewrite the problem. This is going to be 3 over 2 in front of an x, that's what this means, minus, this is a 1 in front of x, that's what this is, and then minus 9 over 2. I'm just going to stick that to the back. And now I need to put this together. I need to put 3 halves and take away 1. So I do this on the side, minus 1. And get a common, or not a common, sorry, turn this into a fraction, and then just do the little cross thing that I showed you. It's going to be 3 minus, that's going to be 2, and then over these two multiplied, that'll be 2. So we get 1/2. So this becomes 1/2 x minus 9 halves, and we are done. So there's a big difference between solving equations and just simplifying expressions. And in your homework, you'll have an opportunity to practice this more. So that completes that section, and this is the homework for order of operations and linear equations. So this is the homework that I assigned last time, right? I told you to do these 1 through 15, but now you should be able to do the rest of these. And there's a lot in here, and there's a few that I didn't talk about. like in terms of like decimals, but I just want you to see how you do with it. So there's a lot of problems there. So in your schedule for the class, we can now do the rest of these. So go ahead and everything here and here you should try to complete. All right, we're moving on unless anyone has a question. Got about 45 minutes left. Okay, so this next section, polynomials, operations with polynomials, applications with polynomials, and then greatest common factor, I'm going to go pretty fast through. All right, I really tried to take my time through the linear equations because solving linear equations is one of those things where if you can't do that, then it's going to be very difficult to do anything else in the class. So I wanted to really make sure that we didn't blow through it so fast you were lost. When it comes to polynomials, you first have to know what a polynomial is before you can talk about doing anything with them. So in general, a polynomial is just an expression that has variables like x or a or b or r, whatever it is, and that it's those variables are raised to different powers. So for example, we have 3a, that a is raised to the first power, plus 2a squared plus 3a cubed, and then we're subtracting from it a plus 2a squared minus 3a cubed. So these are all polynomials. Everything in this parenthesis is polynomial, that's polynomial. And here we're subtracting the two. Here's a polynomial, we're adding another polynomial. Here's a polynomial, we're subtracting another polynomial. Here we're squaring a polynomial. Here we're multiplying a polynomial. Here we're multiplying and subtracting. So this section is all about how do we do these operations. So the thing that you need to, I guess, be most familiar with is the idea of like terms. And we've already discussed this, when we were adding like 3x plus 2x, that would be 5x. And all you're doing is adding the numbers in front. But if I changed it to 3x squared plus 2x squared, then that would become 5x squared. So it's the same concept that you're just looking at the numbers in front. But what has to match for you to add things together is the variable has to be the same and it has to be raised to the same power. So historically, students do okay with this. So that's why I'm going to go quickly through it. All right, let's look at the first one. What I need to do first to do this operation is I need to get rid of the parentheses on both of these. So you need to see that there's a 1 in front of this parenthesis, and here there's a -1 in front of that parenthesis. And then we will distribute through and distribute through. So if I multiply everything by 1 on the first polynomial, nothing changes. Everything stays exactly the same. But if I multiply -1 through the second parentheses, all the signs change. So everything that used to be positive is now negative, and everything that used to be negative is now positive. So that's the effect of multiplying through by -1. And then we begin collecting the like terms together. So let's just start with the a's. I have 3a here. I have another a right here, minus a. Then I'm going to do the a squareds, those two. And then I'll do the a cubes, which would be these, add those together. So let's call on somebody here. Let's see, Bela, I think I called on you already, but you don't have your mic. How about Juliet? Juliet, are you there?
Yeah.
All right, so are you okay with me up to this step?
Yeah.
Okay, so can you combine those together? Start with the yellow ones.
Okay, it'd just be 2a.
2a, okay.
And then the a squared would just cross out, right?
Yeah, they're gone because one of them has a 2, the other one has a -2. They kill each other off and it's over, right? How about the a cubes?
And then 6a cubed.
That's right. So everyone, it's 6a cubed, right? Not 9. You're not multiplying the 3 and 3 together, you're adding them. So that's how we combine polynomials together with addition and subtraction. Okay, good. All right, everyone, let's look at the second one, number 2. And same story, we want to get rid of the parentheses. So I realize there's a 1 here and there's a +1 here. And when I distribute through, a +1 changes nothing. So we have 3a plus 2a squared plus 3/5 a cubed plus 6a minus 2/5 a squared minus 3a cubed. So just get rid of the parentheses because there's ones in front of both. Then look at what's common. So I've got a here, that one has an a. I've got a squareds here, and then I've got a cubes here. So the big difference between this problem and the previous one is that when we try and combine these together now, do you see that we have some fractions here? And that's going to kind of suck because we have to put fractions together. What Juliet just did was just adding nice numbers, right? Like, 3 minus 1 gave us 2, and then 3 plus 3 was 6. But here, it's not going to be as nice. So let's start with the yellows. These two together, that should give us 9a. That was the easy one. Now let's do the blue parts here and here. So to put those two together, what I have to do, I'm going to do it in the top corner here. I have to do 2 and take away 2/5. Which means I should probably rewrite the 2 as a 2 over 1. And then do that shortcut subtraction of fractions. Where I do 5 times 2 gives me 10. Take away 1 times 2 gives me 2. Multiply 1 times 5 gives me 5. And that should give me 8 over 5. So the blue parts come together to give me positive 8/5 a squared. And let me see, I'm going to call on someone. I'm going to give everyone 30 seconds to try and do the yellow part, and then I'll call on someone. How do you put those two together? Let's see. I've actually called on everyone today. It's good. Let's give Jamal another opportunity. Jamal, are you here? No. No, Sergio. Piero. How about Evelyn? No. Okay. So how about a volunteer? Someone want to tell me how many a cubes we have?
I got 18 over 5 a cubed.
Is it okay? Did you get positive or negative 18 over 5? Are you doing, did you do this? Did you do 3/5? That's the number in front of a cubed here.
Yes.
And did you do minus 3 over 1?
Yes.
Okay. And then when you multiply here to here, you get 3. And then I think this is the problem because it's a minus here. You've got to do minus 15. I think you did plus.
Oh, yeah, I did plus 15.
And then over the 5 times 1, which is 5.
Mm-hmm.
And then when you do 3 and take away 15, you should get negative 12 over 5.
Over 5. Okay.
So minus 12 over 5 a cubed is the answer there. Okay, I'm going to leave number 3 to you to do, or I'm not going to do number 3. It's very similar to these two. Number 4 is a little different. Number 4 says take 4x minus 3 and square it. So what that means you have to do is take 4x minus 3 and multiply it times 4x minus 3. What you do not do is just square each of these individually. You don't just square the 4x and square the 3. You have to do this. And this is the first time we've talked about this. How do you multiply two polynomials together? So does anyone who kind of knows how to do this want to share their, like, the explanation of how to multiply these together?
You would FOIL them out. So you would do like 4x times 4x and then 4x times -3 and then like so on.
You said FOIL, right? So FOIL is this thing that you learn in math classes. It teaches you how to, it gives you a cute way of remembering how to multiply two terms times two terms. And it stands for first, outer, inner, and last, which is fine. If you like this, you like it, okay? And I'm not gonna tell you to not do it. But I prefer to show my students kind of a different way of thinking about it, because this works great, okay? This works great if you've got 2 here and 2 here. But what if you have like number 5, 2 here and 3 here? Or what if you had 3 and 3? You can't use FOIL. So the procedure I'm about to show you will work for anything. All right, so here's the idea. What you're going to do is start in the first parentheses and look at the first term. And you're going to distribute just that term through the other parenthesis. You can do those 2 multiplications. After you do that, you're going to move to the next guy in here and distribute that to the other parenthesis. And after you're done moving through the first parenthesis, you are finished, okay? So let me back it up. I'm going to do it. So I'm starting with the yellow. I'm going to distribute here to here. That gives me 16x squared, because 4 times 4 is 16, and x times x is x squared. Then I do here to here. That gives me a positive times a negative is negative, so I get negative. And 3 times 4 is 12, and then I still have the x. Then I move to the green and I do the middle multiplication right there. -3 times 4x is -12x. And then I do the last one right there, which is going to give me +9. The only thing left to do is combine those 2 together because they're like terms. -12x and -12x is -24x. And then I can put that together with the other 2 terms and I have my answer. So again, if you like FOIL, use FOIL, but look at number 5. If I do number 5 using the same procedure I just showed you, you're going to start with the x, hit through the parenthesis, then move to the -3 and distribute through. When we do that, we're going to have a total of 6 things multiplied. So when I do my first one, I get x cubed plus 3x squared plus 9x. That was x times x squared, x times 3x, and x times 9. And then I multiply the -3 through, so I get -3x squared minus 9x, and then minus 27. Are there any questions on how I did that? How I was doing, starting with the first one, distribute through, then move to the second one, distribute through? Is that clear? Now you can combine some like terms together here too. Oh wow, look, there's a lot of things that go away, don't they? That and that can't kill each other off. And the 9x's kill each other off. So all you're left with is x cubed minus 27. All right, the last one I'll leave to you. You would first do this, which would be like the FOIL. After that, you subtract this, which is very much like the first problem. So I'll leave that as, you'll see more of that in your homework. So, okay, on the applications for this, there's a few things in geometry you have to know to do these problems. You have to know what the perimeter of something is in the area. So the perimeter of an object is the distance around the object. Like if you're trying to walk around it, the perimeter is the distance around it. And then the area, you need to know that the area of a rectangle, if I give you a rectangle, if this is the length and this is the width, that the area is the length times the width. So I'm not going to work these problems out. I'm just going to talk you through them. So this one says, write the polynomial that represents the perimeter of this triangle. That means they want to know what the perimeter is in terms of these sides. So that means you have to take this polynomial, add to it this polynomial, and then add to that this polynomial. So it would look like, 3x minus 4x plus 9. That's the first side. I'm going to add to that the next side, 5x plus 3. I'm going to add to that the last side. And this is just a bunch of additions. So I'm going to leave that to you. You'll do that the same way we did these up here. For number 8, I want you to think about that. And I'm going to give everyone 2 minutes. And then I'm going to ask for a volunteer to explain to us how to do number 8. So let's take 2 minutes for that. Read the question and see if you can come up with it. I need to move this out of the way. Oh. All right. Somebody get it? Want to go out on a limb?
I don't know if it's right, but
What do you got? You got to take a swing, right? You never hit a home run unless you take a swing.
yeah. I got 4x squared minus 25.
Okay, let's see if that's it. Somebody get something else?
Yeah, I got
Yeah.
2 squared minus 20 plus 25.
Wait, what did you get, Dina?
2x squared minus 20 plus 25.
I got 4x squared plus 25.
Okay, Dina, it was 2x squared minus,
20 plus 25.
did I write that right?
Yes.
Okay, all right, so let's see. We are trying to find the polynomial that represents the area of the shaded region. So we want to know the area of just this gray. All right. So the way we can do this is we can try and first find the area of the big rectangle and then subtract from it the area of the small rectangle. So it's like, imagine that you want to do the area of the whole thing and then come take away from it that little area in the middle. So the area of the big rectangle will be this side times this side. So that's going to be 2x minus 5 times 2x minus 5. That's the area of that one. Then subtract from it the area of the inside one, which has sides x and x. So that's just x times x, which will be x squared, but I'm just going to leave it like that. Does that make sense to everyone? All right?
Yeah.
Okay, now I'm going to FOIL. So I'm going to multiply here, here, and then here and here. So I should get 4x squared minus 10x plus 25. That's everything FOILed out here. And then I still have minus x squared there. Right? I still have this. Now combine like terms. So what do we get? How about our x squareds? I've got that and that. How many x
3x
squared?
squared.
I have 3x squared. So I have 3x squareds. How many x's do I have? Negative 10, take away more 10 more.
Negative 20.
X. And then I have a number by itself, plus 25. That's it. So nobody got it. It's okay. Nobody got it. But that's why we're here. We're here to learn, right? So are there any questions, or do I need to clarify anything on this problem? Let's see a chat here. Let me see. Where did the 3x squared come from? The 3x squared came from the fact that we were doing 4x squared and we were taking away a 1x squared, which would be 3x squareds. That good, Bela? Okay. Any other questions on that? Okay. We're moving on again. So that this is applications. Let me see. Number 9, perimeter. Yeah, you just add all those up again. Yeah. Let's move on to our last topic for the day, which is going to be greatest common factor. Now, what I'd like to do is start this by reminding you that you've already learned how to distribute, right? We've done it several times. When we distribute something like, let's say 2 times x minus 5, we're just multiplying the 2 through, and we're getting like 2x minus 10. Or if I gave you this, how about 2x and then x minus 5? Instead of just 2, 2x and then x minus 5. You could distribute the 2x through, and you would get 2x squared minus 10x. The idea of distribution is something we've been doing today. What we now want to talk about is the reverse operation. So like from left to right, that's called distributing. But if you try and go the other way around, go from right back to left, so from this back to that expression, or you go from this back to that expression, that's called factoring. And I know all of you have taken math classes and you remember the word factoring. And it's something that causes lots of trouble for students because factoring can be complicated, very complicated. But when it comes to factoring, anytime you factor, anytime ever that you factor, the first type of factoring that you ever want to try and do is called the greatest common factor. So when it comes to factoring, step 1, okay? First step is always to do what's called GCF, which stands for greatest common factor. So let's just do an example. All right, let me do an example. We're gonna start with this one right here. If I take 2x minus 10 and I ask you to factor it using GCF, greatest common factor, what I'm telling you is to look at the terms and see, first of all, is there a number that divides into both of these numbers? So what is the biggest number that goes into both 2 and 10? So you have to think about that, right? What number goes into both 2 and 10? And you conclude, oh, 2, right? 2 goes into both. So what you're gonna do is write down a 2. Now what you ask yourself is look at the variable. Is there a variable in both expressions? There's not, right? There's only a variable in the first one. So these two terms both have a 2 in common, but they do not have any letters in common. So this 2 is my only GCF. It is my greatest common factor. So what I do after that is I write down a set of parentheses and I give myself enough space for 2 pieces in this parenthesis. And those 2 pieces, the reason it's 2 is because I started with 2. So what you're going to now think, this is all a mental thing. You have to say, what do I multiply this 2 by? So what would I have to multiply 2 by to get back 2x? So what would have to be right here so that when I distribute, I wind up with a 2x? So what's missing, in other words? So what's missing? I just need an x, right? Just an x. If I multiply 2 times x, I will get back this. And then you play the same game for negative 10. So what would you have to multiply 2 by to get negative 10?
Is 5.
Yeah, and that'll go here, minus 5. So we know that this can be rewritten as 2 times x minus 5, which is where I started up here, right? If I wrote 2 times x minus 5, you can distribute and go this way. GCF is going to take us from here back to this. I'm going to make up a completely new one. 3x cubed minus 21x squared. I'd like us to try and factor this with GCF. So really what it comes down to is this. We want to be able to rewrite this where there's a set of parentheses, and in this case, there's going to be 2 pieces in here, and out in front of this is going to be a greatest common factor. Something goes here. So let's go to Tiffany's not here. Cheyenne. Oh, Cheyenne's not feeling well. How about Elisa? Are you there? Okay, how about Katrina?
Yes, I'm here.
Still there, okay, good. So Katrina, when you look at these 2 terms, let's start with numbers. Is there a number that goes into both 3 and 21?
3.
3, okay. Is that the biggest number that goes into both?
Yes.
Yes, so 3. Okay, now, in terms of x's, Katrina, they both have x's, don't they?
Yes.
Okay, so this is where it's weird. You have to factor, your greatest common factor will be the most number of x's that appear in both. So do these both have at least 1 x?
Yes.
Do they both have 2?
Yep.
Do they both have 3?
No.
No, but so the most that they both have is 2, right? So we put an x squared on the outside. Once you've determined that, Katrina, now you just have to answer the question of what goes in these 2 places. So Katrina, what do I multiply 3x squared by to get back 3x cubed? Or in other words, what's missing?
Just an x.
Just an x, so I put that here. And then the next one, I have to turn 3x squared into negative 21x squared. What do I need here?
7.
7, okay. And positive or negative?
Negative.
negative because you needed the 3 to become a negative 21, so you multiply by negative 7. X squared was already here, so you don't need to add any x's over here. So everyone's going to be a different place here. Why don't you try these? Let's take a few minutes here and see if you can do all of these on your own. This will be interesting to see where people are. Can everyone see those okay? I'm making them a little bigger. Try and do all 5 of those problems. And I'll give you a hint on the last 2. Well, actually, I'll set these all up. You're trying on this first one to factor something out. You'll need 2 things here and then something out here. Here on this one, 2 things here because they start with 2 and then something here. This one, 2 things here and something here. But on the last 2, you're going to have 3 things here and something out here. That'll be the same for this last one. 3 things and something in the front. So see what you do. I'll give you, what do you think? You think like 6 minutes is enough time? Try 6 minutes. Okay, go for that. I'll reset my clock here. Okay, see what you can do. I think on this one, I'm going to start writing the answers down, and then you can see if you're getting the same thing. Okay, I've put the answers here. And I want to open the floor up here to any questions on how I got anything here. This is one of those topics where it's like, if you get it, you get it. If you don't, then, you know, it's like a light bulb that kind of goes off. Just got to be careful. Yeah,
I
go
have a
ahead.
question about number 11. Sorry.
Okay,
Do we have to put the +1?
yes.
Okay.
Are you saying, could you have just done 6 and then y squared?
Yeah.
Okay, I'm glad you asked that question. If you write just 6y squared, 6y squared is just 6y squared. You need the +1 because you need it to distribute to get the 6, right? If you don't have the +1 there, then there's nothing to distribute here. And it's just 6y squared, which is not the same thing.
Okay, thank you.
Good question. I'm glad you asked. How about any of the other ones? Does anyone need some clarification?
On 14, why is the y outside of the parentheses but not the x like how 15 is?
Okay, on number 15, why is the y? Oh, why is it on number 14?
Yeah, like see how the y is outside of the parentheses, but
Yes.
not the x. Why not the x like how it is in 15?
Okay, so what we would need in order to be outside the parentheses, whatever's out there has to be present in each of the terms. So this has an x squared in it, right? This has an x in it, but this has no x's, right? So it has to be common to all of them, not just 2 of them or not just 1 of them. It has to be common to all of them. So since there's no x in all of these, we cannot pull an x out in front. Whereas with this last one, we have x cubed here, we have an x squared here, and we have an x to the 4th here. So what they all have in common is at least 2 x's. Does that help clarify that?
Yeah, that makes sense.
Yeah. Okay, we have more to do, but according to our calendar, I knew we'd be a little bit behind. What you should be able to do now with homework is these 3 sections here. We were supposed to cover all of this today, but like I said, I'm taking my time. So that means that we are going to have our first exam on Monday. And that first exam will cover everything with the exclusion of percent, proportions, application, and mixtures. Immediately after class, I will be sending you a review for this first exam, all right? And then later on this weekend, I will send you the solutions to that review. Your goal is to be able to do that review without any issues. If you can do the review, then you should be able to come in on Monday and take the test, okay?
Is the exam multiple choice or is it like writing the answers out?
It's writing everything out. So all your problems are going to, well, you know what, let me show you. I'm going to just bring up an old exam so you can kind of see, let's see, where do I want to pull from? I'm trying to think of the last time. No, it would have been in the fall. Here's a review for an exam that I gave in the fall. So this is gonna, don't worry, I'm gonna send you all a review, okay? Yeah, this is actually pretty close. It's, you know, adding and subtracting fractions, multiplying and dividing, order of operations, solving a linear equation, simplifying a linear expression. This looks very much like the problem that we just did a minute ago that I had you do. Factoring out a GCF, and then simplifying some polynomial expressions. So this is pretty much, this review is actually, I'll probably just send you all this review. This is pretty much what our,
Are we able to Is this on the exam?
Pardon?
Are we able to use the review for the exam?
No. What do you mean? During the exam?
Yeah.
No. So during the exam, remember from the first class, what I said on Monday was everyone's going to come in here on Monday and you're going to have your cameras, you know, set up like they are right now. I'm going to email everybody the test. And then at that point, you're either going to print the test out if you have a printer, or you're going to handwrite all of the problems on a separate piece of paper. We'll take the first 10 to 15 minutes of class to do that. Then I will say, okay, the test is starting now, and everyone will have to put all their stuff away except for their handwritten test and blank paper. And then you will take the test, paper and pencil, by hand. But your cameras, remember I showed you the picture? You have to be able to move your camera into a position where I can see you and your entire workspace. And that way we know that there aren't some people who are using the review, you know, and that would be considered cheating, right? So you take the test, and after that, then you have 15 minutes from when you finish the test to submit your work to me. Now, I did send everyone that Dropbox link on the first day, and let's see if anyone's done. I know I had like 2 students had done it. See how many I have now.
Oh, sir, if we have a calculator like the one that you had for on the syllabus, can we use that on the test or no?
Yes, you can have a calculator, but here's the danger in the calculator. When I'm asking you to do this, right? I'm asking for you to do that by hand, showing me all the little steps. You can use your calculator to check your answer, but I need to see the work. This is not a can you use your calculator test. This is a make sure you understand how to mechanically add, subtract, multiply, and divide fractions, especially for problems like this. Like if all you do is give me an answer here with no work, right? That's not what I'm looking for. I want you to show all your work. So I'm a little concerned here. Only 4 of you have tried to submit me stuff online. Let's see if these look okay. All right, so let's see. Someone sent me a file and another one sent, this one looks like a folder. That's just a folder.
Was it supposed to be a file? I thought it was a folder.
It is a file. You're supposed to send a single file.
Okay, my bad.
It's okay. It's okay. Let's see. Dina, can I open this or no? Are you okay with that?
Yeah, sure.
Okay, so let's see what Dina sent us. Okay, so this is perfect. Dina sent a file that has 3 pages in it. And that's good enough. Yeah. So I've given everyone the opportunity to practice this. Dina, you're in good shape. You're ready. You understand how to submit. So when the test comes on Monday, you'll be able to send me your work. Everyone needs to be able to do that. So let's see, Bonnie, can I open yours?
Yeah, you can. Sorry, I was on mute.
Okay, that's okay. So same thing, Bonnie sent, this is good. This works. 3 pages. Those look like pictures from your camera. Yep, that's perfect. Okay, that's what I'm looking for. So please make sure you can do that come the test time, because I only give you 15 minutes from when you finish the test to get that to me. If you don't have it to me within 15 minutes, I won't accept it, because then theoretically you could be sitting there, you know, having someone help you do the test, and you know, I'm trying to be fair to everyone. So are there any questions on that, the procedure? This first exam is going to be bumpy, okay, because it's the first time we're doing it, but are there any questions on it in terms of what I'm expecting on Monday, the camera, how you need to get it set up? Does anyone have any questions on that?
Not for the camera, but when we turn in the PDF file, we also take a picture of the test and all the work shown, right?
What I need from you when you submit the test, the pictures, is just your work. That's the most important thing. It's just your handwritten work with your answers.
How much time do we get for the test?
So I'm gonna probably take 15 minutes in the beginning of class just to get this class, get the test started. And then I would say probably an hour to an hour and 15 minutes. And then I'm gonna stop the exam. Everyone will have 15 minutes to send me their work. And then I'm probably gonna have to continue class. Because we're already a little bit behind. So I would anticipate coming in to class at 11, probably working until about 12:30 on the test, and then taking a little break, you know, for people to submit their work, and then coming back at like 12:45 to go for another 45 minutes or so, or an hour. Just so we can at least get into percents and proportions, because we don't want to be too far behind. So does that answer the question? At least an hour for the test?
Yes.
Okay. Yeah, it won't be the whole class period. It won't be the 2.5 hours or 3.5 hours, whatever it is. 2.5. Okay. Anyone have questions about the camera setup? I wanted to show you again. We go to our, you know, what I'm looking for is this idea of me being able to see you in your workspace. That's what I'm shooting for. So if it's just, you know, if it's just a portion of you and a little bit of your desk, that's not going to work. I need to be able to see what's in front of you and what's around you. You sure we're clear on that?
Yes.
Okay. All right. Well, we have 5 minutes or so. Did you all want to see the end of that thing I was talking about with the kid or no? I mean, we can call it a day. It doesn't matter to me. I can show it to you if you want. Remember the story?
Oh, yeah.
If you want to go, you can split. You're not going to hurt my feelings. But I'll just finish this out. I told you this story about this kid in kindergarten where the teacher told him to add up, you know, first 3 numbers, 4 numbers, 5 numbers, and then add up the first 100 numbers. And then Gauss comes and gives him this formula, right? So the story goes, this formula was known. Okay, so at the time, like the formula was already known. Gauss didn't come up with the formula, like no one had ever seen it before. But for a kindergartner to come up with that formula, the teacher asked him, you know, who showed you that? And Gauss was like, nobody showed me this. I came up with it on my own. And the teacher didn't believe him and like took him to the office and principal. And so he had to explain, Gauss had to explain how he came up with it. All right. So I'm gonna show you. I think it's pretty genius. Okay, so watch. Let's just take this example. This is kind of the way he did it. He said, look, I'm supposed to add up these numbers, right? All the way to 100. And so the way he visualized this is with blocks. If I take a block, that's a single block, that's 1, right? If I take 2 blocks, you know what? Let me get my graph paper up here. It'll be easier. So he said, here's 1 block. Okay, there would be 2 blocks, right? There's 3 blocks, 4 blocks, right? And let's just do this. Let's just do this for the first 5, okay? Just to make this easy for us. If we do just the first 5, that's what it would be, right? Okay, so if I could figure out the area of this, that would be what all these are added up to be, right? The area of that little square is 1. The area of this and this together, that's 2. The area of those 3, that's 3, and then 4, and then 5, right? So Gauss said, look, let's just take this. I don't know if I'll be able to do this. Copy it. Let me try to paste it. Can I rotate that? Yeah, let me rotate it. Rotate. So Gauss said, I'm going to take basically a copy of that same picture and I'm going to stack it on upside down like this. Okay. Now, he's made a copy. right? So he's doubled, the area of all of this is twice what he's looking for. Do y'all agree with that? But let's take a look at what happens here. How wide is this? Well, it was 1, 2, 3, 4, 5. So that's 5 wide. But can you tell me how tall it is now?
Wouldn't it be 6?
It'd be 6, right? Because the last block was 5 high, but then when you flip that one over and put it on here, now it's 1 higher. And it fits in there perfectly. So all of these should be 6 high, right? So the answer to this should be 6 times 5. But half of it, because remember, we doubled it, right? It'd be, so he just said, oh, okay, just take the area of the whole thing and then half it. And that would be the original one. Does that make sense? So he said, if I want to do 1, then 2, then 3, and then all the way out to, let's say, 100, right? Let's say that last one is 100 tall. And it's got all these steps in it, right? Steps all the way down. If you make a copy of this and flip it over like that, how wide would it be?
100.
100. And how tall would it be?
101.
101. And so if you wanted to add up the first numbers all the way out to 100, this should be 100 times 101. But half of that, same idea, right? Okay, so then the argument goes, what if I started with a block here at 1, then there's 2, then there's 3, but now instead of stopping at 100, what if I stop where this is n? So n could be 100, it could be 5, it could be whatever you want it to be. If you want me to stop at 1,000, if you want me to stop at 2 million, let's just say that that's how tall this last one is, right? You got all these steps in here. Make a copy of it, flip it over like that, flip it over. How wide is it?
Wouldn't it be like n?
It'd be n, right? And how tall is it?
N plus 1.
N plus 1. And that means that if you took 1 plus 2 plus 3 and you added it up and you stopped at n, it should be this times this, n times n plus 1, but half of it. And that is exactly what, where'd it go? I don't remember where I put it. Oh yeah, there it is. Okay, so that is exactly what he had when he flipped his little tablet over and showed it to the teacher. That's the formula he had. So I think, I mean, obviously, at least one of you followed this, right? That's pretty clever thinking for a kindergartner. As you might imagine, he did some really outstanding stuff in math later on in his life. He's a very famous mathematician. But I think this is what makes geniuses geniuses. They take a problem that seems so difficult to do, and they come up with some way of looking at it that you can show to someone else, and they're like, okay, you know, like, yeah, that makes sense, you know. Yeah, so it's clever. He wound up not getting in trouble for that, obviously, but. All right, so I call this the birthday candle function. So like, let's just imagine that you've blown out candles on your birthday for every birthday you've had, right? So like when you were 1, you blew out your candle, and when you were 2, you blew out your 2 candles. And so like if let's say that now you're like 23 years old and you want to know, how many candles have I blown out? Well, you blew out 1, then 2, then 3, then 4, right? All the way up until 23. But that's just going to be 23 times 24 over 2. So you just get your calculator out. 23 times 24, divide that by 2. You've blown out 276 candles. So it's an easy way to add up consecutive numbers. Okay, that's it. We're out of time. Look for that review. I'll be sending that out here shortly, and then I'll see you on Monday for the test.
I
Any
just have
questions?
a question. I just saw your email. Am I able to call you after this, or do you have like a class or anything like that?
I don't.
Okay.
Email about.
I'm getting like tested for.
Oh, yeah. Okay. You know what? If you can just hang out, can you just hang out for a minute, and then I'll answer any other questions, and then we can just talk about it once everyone's gone.
Okay.
Okay. Anyone else questions?
Yeah, I'm confused on how that app you told us to get, the cam scanner. I'm confused on how you use it.
How to like take pictures and send?
Yeah, I know. I get the taking picture and putting into PDF, but it's like the sending part I don't get.
Okay, so what you need to do is go check your email. Okay, so go to your Canvas email. Let me see what I sent here. So you're telling me you have a file that has multiple pictures in it right now on your phone or something?
Well, it just lets you take a picture of like the page like I wrote on, and like it scans it, right? And then you just press like share in PDF, and then I just press that, and then.
But will it let you take multiple pictures and put them into a single, it's like save it as a PDF file? Because I know you're trying to share it. You're trying to share each picture?
Yeah, I don't know how to do that.
Okay, so what are you using, Cam Scanner?
Yeah, I got that app that you said.
Okay, so let me see. Cam Scanner.
Oh, and then, sir, will there be like a different link to put like the pictures on a PDF, or do we just use the same one that you send?
Send a new one. I'll send a new one. Okay, so on your Cam Scanner, Julia, when you open the app, can you go into your what do you call it, camera roll?
Yes, you can go into your camera roll.
And can you select multiple pictures?
Yeah.
Okay, and then can you save that as a PDF? Not don't put share, I guess, put save. You know what? Let me go grab another phone. Okay, I'm looking up Cam Scanner so I can figure out what you're saying. Hey, Julia, are you still there?
Yeah.
Does your app look like that symbol? You see that?
Yeah.
Okay. I'm trying here, trying to get into this stupid phone. Okay, I'm downloading the app, so just give it a moment.
Okay.
Touch to install. The whole idea here, Julia, is that you're going to get all your pictures into one file, and then you're going to probably have to like send that to yourself as an email or something. And then when you go to Canvas, can you see my screen still?
Yeah.
What you'll do is you'll go to Canvas and you'll click on this link, and you'll be able to upload. You'll add the file here. Does that make sense?
So
We'll try it. We'll practice it. Let me just get Cam Scanner open and then okay, continue. Come on, continue. Okay, PDF. Okay, so I'm seeing a page here. Let me see if I can share my screen here. This is what I'm seeing. Are you seeing something like that?
Yeah.
Okay, so let me try this. I would say scan docs with Cam Scanner. And then now I would take, so it's giving me my camera now and I can take pictures, right?
Mm-hmm.
And do you see where it says single or batch? Do you see that on the bottom?
Yeah.
I would say batch,
Okay.
and that's going to allow you to do multiples, okay? So I'm going to just take some pictures here. Picture, and then continue, and then another picture. Continue. I'm going to do 3. Continue. Yeah, I don't know when I'm done. How do I say I'm done? Okay. So after, when I was, okay, so I've taken 3 pictures and they're all in the bottom right-hand corner of my screen. Do you see that?
Yeah.
Okay, now hit that, hit the little window that has the, however many pictures you took, it has a little number next to it,
Okay.
right? Just hit that
Mm-hmm.
and hit the check mark and it should, yeah, it should create a file. Did you get that or no?
Yeah. It just looks like the pictures you took.
Yeah. Now, do you see where it says tap to collage all images in the document as one?
Yeah.
Okay, now I'm trying to figure out where that collage is. Tap collage. Jesus, this is complicated. Yeah, just get through, if you get through the little like introductions, it should take you to where it shows all of them in one. You see where it shows all of them in one document?
Yeah.
And then you can save that.
Save. Okay.
And just don't get the premium. Where do we save this? Okay, this is not working. This is what all my students use, so I'm not sure what they're doing different than what I'm doing. Okay, let me try something. Okay, so go back to where you have all three, right? Like this, or whatever, all your pictures, and just go to email and just email it to yourself.
Okay, so just press email.
Yeah, try that. And then share PDF.
Okay.
Send it
To like
So-
my personal or my school email.
just to your personal email, and that way you now have it.
Okay.
And then once you do that, open it up and see if it works.
Yeah, send it to my email as a PDF.
Okay, now have you opened it in your email?
Yeah.
And did it have all three pictures?
Yeah.
Okay, so now go to your Canvas email. All right. Open up your Canvas email. And you'll see an email from me. I'm sorry, Caitlin. I haven't forgotten about you. Open up your email from me.
Okay.
It should say Dropbox practice or something like that.
Mm-hmm.
And click on that link.
Okay.
And when it says add files, add the file from your email. Now, when you checked your email and the file was there, you might have to actually download it to your computer. I don't know if you're doing this all on your phone or what, but that file you emailed to yourself now needs to be added here.
Okay.
Let me know when you got it, and then I'll take a look. Diane, were you wanting me to check yours?
Yeah.
Yep, good. Yep, that's what I'm looking for. Perfect.
Thank you. Okay, so I did it, but at the end it asked for like my email address. I just put my school one.
Yeah, that's fine.
Okay.
It asks you for your name.
Yeah.
Okay, yeah, name and email or whatever. That's fine. Do whatever email you want, as long as your name's there. I know this seems tedious the first time it is, but you'll get better with it.
Okay, did it work? Oh,
Yeah,
okay.
so you see, I have it here. Let me just take a look. Yeah, it's 2 pages.
Yeah, that was just my notes.
Yeah, that's it. Okay, that's exactly what you need to do.
Okay, perfect. Thank you.
Okay, no problem. All right, Caitlin, it's just you and I now.
Oh, is my mic working? Okay, yeah,
Yes.
it is. Yeah, so I'm getting tested for like accommodations on like the day that we're taking the test, but my like doctor's appointment would be like right after like we would finish the test, so I don't think I'll be able to be a part of like the next
Second
like
half.
yeah.
Oh, I thought, see, I misunderstood the email. I thought you were telling me that you were going to want to take the test in a different setting with like proctoring from something else.
Oh no.
That's what I thought. Okay, because like normally students with accommodations on like face-to-face on campus can sometimes go to the testing center to do their test. And so I thought you were going to be doing some like Zoom testing center thing, and I was happy to do that, but I just want to make sure I understood that.
Oh no, I'm just getting tested for accommodations.
Okay, okay, so you're just going to be doing it normal with everyone else in the beginning, just at the second half, you probably won't be there.
Yeah.
Okay, that's no big deal.
Okay, thank you so much.
Sorry,
Also,
thank you. Yeah.
that one link that you like for practicing to submit the like files, is that the same link where we would actually submit the test?
No, I'll send you a separate link for that. And
Okay.
I'll do that on Monday.
Okay, thank you.
Okay, yeah, sorry to make you wait for that. Okay, take care.